Welcome to video 1B, section module 1 in your Keystone review. So in this video, I promise it'll be short, we're talking about systems of linear equations. So think about a system. It is two linear equations that you're solving at the same time. The solution, if there is one, is going to be a point that both of those lines meet. So if you're graphing, it's easy to see where they intersect that point. Don't forget, you've got an x and a y value there. So over the course of this year in Algebra 1, you've been learning about solving these systems, and most of your teachers have taught you three methods: graphing, substitution, and elimination. So depending on how the equation is set up, is going to kind of depend on how you probably want to solve it. Some of you are going to be much more comfortable with graphing it. However, if your equations aren't in slope-intercept form, it makes it a little tougher to graph. And you run the risk of having some errors with signs and things if you try to graph everything. So that's why your teachers have given you three different options for solving. It doesn't necessarily mean one's better than the other, but one is usually more efficient depending on the setup of the problem. So with something like this is a system, and it is going to, in this case, I would personally solve this by elimination, because I have everything lined up and they're both in standard form. With this, I would have to multiply my second equation by a -2 in order to eliminate my y's. But again, it's possible. It's just, there's an extra step there. If you wanted to solve this by graphing, you would have to rearrange both of these equations into slope-intercept form, and then you could use your graphing calculator. And here are the steps for solving this system by graphing. So make sure each equation is solved for y. And again, we've talked about what does that really mean, solving for y. We're just rearranging the equation so it's in y equals form. Then you can put both of your equations in your graphing calculator. And then to make sure you can see the point of intersection on your graph. So you want to look at the graph, make sure your window is set so that you can see where the lines intersect. And then if you press the second button and the trace button on your calculator and hit enter 3 times, it will give you the x value and the y value of your solution. If you're going to solve this system by substitution, you only have to rearrange or solve one of the equations for either y or x, okay? So you don't have to rearrange both of them to solve for y or x, but just one. You're then going to plug in that material that you solved for either y or x into the second equation, substituting the resulting expression for the variable that it equals in the other equation, and then solve that equation. Now that is only going to give you one of the values, either the x or the y, depending on what you just solved for. You then must plug that value for the x or the y back into one of the original equations, and make sure you plug it into one of the original equations in case you made an error, and solve for the other variable. Now, I always like to add a fifth step there. Plug that value back into the other equation that you didn't just use and make sure it gives you the same value. That's a great check so that your points match up, and hopefully you can move on. Elimination, which is probably my favorite, is nice because if your equations are lined up like they are here, you multiply one of the equations so that you've got opposite values, and then you add or subtract, and one of the variables is eliminated right away. So you want to make sure that the variables are lined up. If one set of variables does not have opposite values, then you're going to either multiply one or both of the equations by a value that creates opposites. You then add your equations, which results in eliminating a variable, solve for the one variable, and again, don't forget, you got to plug that variable back in to find the other variable, because your solution is just not an x or a y, but is that point, that x comma y value that you are looking for here. Okay, so let's look at our options here. So in this case, it says, what is the value of the solution to the system of equations below? And so here's our system, and they're just asking for the x value. Okay, so depending on how you solve this equation, you could solve this using substitution, elimination, or graphing. In this case, I would probably solve this by elimination. And I would multiply my top equation by what? I need to multiply it by 2 so that I eliminate my y's. The nice thing is, if I do that, my solution should be my x value, right? So if I multiply that top equation by 2, I'm left with 2x plus 2y equals 12. I can then take and write my second equation, okay? And subtracting the 2y there equals 20. And then my result, I'm going to write down here, is 8x. My y's are eliminated, equals 32. If I divide both sides by 8, I am left with x equals 4. Okay, so that is my answer. Now, a good check would be to plug that in. So if I plug in 4 for x, 4 plus what gives me 6? That would be 2. So y should be 2, right? Check it with the second one. So 6 times 4 is 24, minus 2 times 2 is 4, gives us 20. So that is a kind of a quick check to just make sure we did the problem correctly. Now, when you're solving systems, remember there are 3 different options for answers. We're used to, and we like it when we get one solution, okay, which is over here, where our lines meet, they give us 1 point. However, there are options when our lines are parallel and they're never going to intersect. And then there is an option where the lines are actually exactly the same. And so you've got infinite solutions. Any value of x and y will be a possible solution here. So as you're thinking through those problems, make sure you work on recognizing that you might not get one solution or no solution, but infinite solutions.